Hi everyone, today we are going to look about basic concepts of physics. First is about objectives. What is objectives? That means what are the topics or what are the categories we are going to follow. That is, it is to understand the fundamental physics and to apply these concepts in radiology, and it is also a building base for imaging physics. First we are going to discuss about units and measurements. What does the word unit and measurement means? It is the units are the physical quantities or the quantities value which are adopted as a standard measurements in which there may be similar quantities can be measured. That is, we can say it as kilogram, meter, second, etc. So these units were classified into two categories. That is about fundamental units and derived units. The units which are independent of one another and having their own standards will be said as fundamental units. That is mass, we say it as a kilogram, and for length we say it as a meter, and for time we say it as a second. So all these physical quantities will be obtained from this fundamental units. Next is about derived units. What does the word derived unit means? That is, these were derived from the fundamental units. So what can we say it is? For example, area. We say it as meter square, and velocity we say it as meter per second, and for density we say it as kilogram per meter cube. So the fundamental units has always been the perfect value, and the derived units were derived from those fundamental units. So next we are going to discuss about heat and temperature. First, what is heat or what is temperature? First, temperature is the measure of hotness and coldness of a body. When a body is heated, its molecules will be in a vigorous movement, and therefore they will have a higher energy, and this object or this body will be said to be in a higher temperature. So, when this body is cooled lower and lower, its kinetic energy will be decreases, and the body will be set as an lower temperature. So the temperature is actually the measure in degrees, and is measured with the help of an instrument which is called as thermometer. Usually there will be three scales in a temperature, that is centigrade scale, absolute scale, and Fahrenheit scale. The centigrade scale, we say it as the melting point of ice will be taken as 0 degrees Celsius, and the boiling point of water will be taken as 100 degrees Celsius. Usually the intervals which is between the 0 degree Celsius and the 100 degree Celsius will be classified into 100 degree, and this type of scale is also called as Celsius scale. And next is about absolute scale. In the absolute scale, the 0 degree we say it will be named as absolute 0, and it will be denoted as 0 Kelvin. The absolute zero is the temperature at which the molecules has a zero speed. That is, the 0 Kelvin temperature is equal to minus 273 degrees Celsius in centigrade scale calculation. Therefore, the temperature of a melting ice will be taken as 273 Kelvin, and the temperature of boiling water will be taken as 373 Kelvin. And the interval between these two, boiling point and the melting point, will be as 100 degrees. Usually this absolute scale temperature scale is also called as Kelvin scale of temperature. Usually in the SI unit we say it as absolute scale. Usually the temperature will be measured in an absolute scale, that is in the Kelvin scale. The next is about Fahrenheit scale. In the Fahrenheit scale, the melting point of ice will be 32 degree Fahrenheit, and the boiling point of water will be 212 degree Fahrenheit, and the total range will be divided into 180 degrees. Usually the body temperature will be about 98 degree Fahrenheit, and will be equal to 37 degrees Celsius or 310 Kelvin. The next we are going to discuss is about heat. What is heat? Heat is a form of an energy that can be transferred from one place to another. Usually there are three methods of heat transfer, within or without. So there will be three types. What are they? There will be conduction, convection, and radiation. I repeat, conduction, convection, and radiation. So first is about conduction. What is conduction? Conduction is a process in which the heat energy will be transferred without the visible motion of the particles of the heated body. And this conduction will be taking place in solids, liquids, and also in gases. Usually, the metals will be a good conductors of heat. Whatever metals we can say, that is about silver, copper, iron, these are all good conductors of heat. And the non-metals will be bad conductors. What are the non-metals we can say? That is plastic, glass, wood, rubber, etc. And what is next is about convection. What is convection? This convection is a process in which the heat energy will be transferred by the actual movement of the particles of this heated body. And usually this convection will be taking place in the liquids and gases because there will be motion of particles, whereas in solids there will be no motion of the particles. For example, we can say it is trade winds and land and sea breezes. Next is about radiation. What is radiation? Radiation is a process by which the heat energy is transmitted from one place to another without the actual or without any aid of any material medium. So usually, for example, what can we say it as? That is the heat energy which reaches the earth from the sun. Actually, the SI unit of heat is as joule, but there is also a special unit called as calorie, which is still in use. That is, 1 calorie is equal to 4.2 joule. Okay, the next we are going to discuss about work, energy, and power. First, what is work? Work is the transfer of energy from one place to another or from one form to another. If we can consider if a force is F and it moves in a body through a distance of S in its direction, then the work done by the force will be given as work is equal to force into distance. That is, the SI unit of work is joule and it is denoted by the letter joule. Next is about energy. What is energy? The energy of the body is its ability to do a work. The SI unit of energy is joule and there are many forms of energy. That is mechanical energy, heat energy, light energy, atomic energy, etc. Usually there are two forms of mechanical energy, that is potential energy and kinetic energy. First is about potential energy. The potential energy of a body is the energy it possessed by virtue of its position. That is, for example, the water stored in a reservoir, compressed air, etc. Usually the work done is equal to force into displacement in this case, that is potential energy is equal to mgh joule, where this g refers to the acceleration due to gravity. The next is about kinetic energy. What is kinetic energy? The kinetic energy of a body is the energy it is possessed by it on account of its motion. That is, for example, moving car or water flow, etc. That is, for a body of mass m moving in a velocity, the kinetic energy is given by the kinetic energy is equal to half mv square joule. Next, we can look what is law of conservation of energy. What is law of conservation of energy? According to the law of conservation of energy, the energy can neither be created nor destroyed, but it can be converted from one form to another form. The next is about power. What is power? The rate of doing work is called as power. Usually the power is measured by the amount of work done in unit time. If W is the work done in time t, then power can be represented as power is equal to work done by time. That is, the SI unit of power is joule per second, and it is also given by a special unit called as watt, and it is equal to 1 joule per second. Usually there is a larger unit of power that is called as kilowatt, and it is equal to 1000 watt. The next topic is about force. What is force? In basic, we can say it as a push or pull of a body is called as force. But what is force? That is, force is an influence that changes or tends to change the state of rest or of an uniform motion of a body along a straight line. That is called as force. If F is the force, which acts on a body of mass m and produces an acceleration of a, then we say it as F is equal to ma. And hence the force which is acting on the body is equal to the product of mass of the body and the acceleration produced by the force on the body, and this is called as Newton's second law of motion. Usually the SI unit of force is Newton and it is denoted by the letter N, that is capital N, and 1 Newton is the force which is acting on a body of mass 1 kg producing an acceleration of 1 meter per second square in its direction. Then usually this is used in medical setups, that is in medical cases, that is to move any objects or to move a person from one chair to another setup, or to move something, to move any other object, that we use this uses force. The next is about Einstein formula. But Einstein's theory of relativity states that the mass and energy are equivalent and they are interchangeable. And in any reaction, the sum of the mass and energy must be conserved. So, Einstein showed that the speed of some nuclear process approaches the speed of light. At this speed, the mass and energy will be equal. That is, hence he states that E is equal to mc square, where the E will be representing as the energy which is equivalent to the mass, and m is the mass at rest and c is the speed of light in a vacuum. So, as per the relativity theory, the mass of the body will not be a constant value. So, if m is the mass of a particle which is moving at the velocity v and mo is the rest mass, then m is equal to m0 divided by root of 1 minus v square by c square. As the particle velocity increases, the mass will also be increases. Usually, this mass energy equivalence theory or this Einstein formula will be mostly used in the cases of nuclear medicine. So, next we are going to look about current, voltage, and resistance. What is current? The current is the flow of charges. That is the flow of electric charges within a material is called as current. Usually the unit of current is ampere. And what is the volt or voltage? The voltage is the amount of potential difference which is formed in the conductor or material which transfers this current. So that is called as voltage, and usually the voltage will be represented by the letter V, that is volt. And next is about resistance. Resistance is a property of a conductor by which it will be opposing the flow of current, and it will also be defined as the ratio between the potential difference across the conductor and the current flowing through the conductor. That is, R is equal to V by I, and the unit of resistance is ohm. Usually in practice we use two units, that is kilo ohm and mega ohm. Kilo ohm will be set as 10 power 3 ohm and mega ohm will be set as 10 power 6 ohm. That is, the resistance of a material will be influenced by three. What are they? That is shape of the material, type of the material, and temperature of the material. Next is about Ohm's law. What is Ohm's law? John Simon Ohm is a great scientist, and he established there is a relationship between the potential difference and current, and he say it is by Ohm's law. That is, the Ohm's law states that at a constant temperature, the steady current which is flowing through the conductor will be directly proportional to the potential difference between the two ends of the conductor. That is, I will be proportional to V, and I is equal to 1 by R into V, that is V is equal to IR. And here that R is a constant, that is we call this the resistance of the conductor. The next is about magnetism. What is magnetism? The magnetism is a fundamental property of a material and it is produced by the motion of the electric charges. Usually, a magnet possesses two poles, namely a north pole and a south pole. And the term this pole will be refers to the ends of the magnet in which the entire magnetism will be appears to be concentrated. The pole that points north under the influence of the Earth's magnetic field will be called as the North Pole and the other will be said as South Pole. As in the case of an electric charge, like poles repulse and unlike poles attract to each other. So when a magnet is broken into two pieces and each part will becomes one separate magnet with North Pole and South Pole. The force of attraction between the two magnetic poles will be given by relation F is equal to m1 m2 divided by 4 pi mu r square. Usually the SI unit of this pole strength is Weber, that will be represented as WB. The next is about electromagnetic waves or electromagnetic radiations. So what is electromagnetic waves or electromagnetic radiations? What is electromagnetic? What is electromagnetism? First, usually an electric charge will be surrounded by an electric field. If the charge moves in a magnetic field, then a magnetic field is produced. So, when the charge undergoes an acceleration or deceleration, the magnetic and electric fields of the charges will vary. The combined variation of electric and magnetic fields will be resulting in the loss of energy. The charge will be radiates this energy in a form of a wave that is known as electromagnetic radiation or electromagnetic waves. That is, it moves in a form of an sinusoidal waves. That is, it is a continuous. Usually, it includes what are the sinusoidal waves? That is, what are the electromagnetic waves? That is, radio waves, microwaves, infrared, ultraviolet, X and gamma rays. So usually these will be having different characteristics. Usually they will be having both wave characteristics and also and particle characteristics. Usually the electromagnetic waves will be processing wavelength, frequency and velocity. What is wavelength? The wavelength is the distance which is between the two positive peaks, and next frequency is about the number of cycles of the waves which passes a fixed point per second, and velocity of the wave is the distance which is travelled per second by the wave. Usually there is a relation which will be relating both the three, that is the wavelength, frequency and velocity of the electromagnetic waves, that is C is equal to nu lambda. All the magnetic waves will be travelling in the same velocity in a given medium. That is, in vacuum the velocity is about 2.998 into 10 power 8 meter per second, and the wavelength of X-rays and gamma rays will be measured in a nanometer, that is smaller in values. So next is about electromagnetic spectrum. What is electromagnetic spectrum? That is, electromagnetic spectrum will be including the radiation from a very long radio wave to short penetrating gamma rays. That is, the spectrum will be classifying the rays which will be produced on the basis of longer radio waves to shorter penetrating gamma rays. Usually all of them will be traveling in a velocity, that is in a velocity c, that is the velocity of light in a vacuum. Usually we will be arranging these electromagnetic spectrum as first it will be coming under radio waves, that is radio televisions and radio waves. Next is about infrared, then that is microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays, and last we will coming about even cosmic rays. So this is the order by which this electromagnetic spectrum will be arranged. So next is about next is about acoustics. What is acoustics? What does the word acoustics means? Or what is acoustics? Acoustics is the word which denotes about the sound waves or the travelling of a sound in a form of waves. We will say it as a acoustics. Usually, there will be variations in the frequency and amplitude of the waves which travel, and that forms the proper way where we can hear this sound waves. And this is usually applied in the field of ultrasound, where the piezoelectric crystals absorbs the ultrasonic waves which travels from the receptor and reaches a target and is received back by the receptor itself and converted these ultrasonic waves to the images which are required by the separate type of software which is found in the ultrasound machine. Then next is about atomic structure. What is atomic structure? We can see this. First we can talk about atom. What is an atom? All the matter is composed of elements and compounds. An element is a simplest chemical entity which cannot be broken further, that is, hydrogen, carbon, oxygen. So, when two or three elements join together, they will be forming a compound. That is, for example, when hydrogen and oxygen mix together, they form H2O, and that is water. And the smallest particle of an element is an atom. That is, it forms the fundamental unit of a matter. The atom are very small and its diameter will be in the order of 10 to the power minus 10 meter. It's the smallest in value. Usually an atom consists of protons, neutrons and electrons. And protons and neutrons are present within the nucleus of an atom, and these electrons will be revolving around the nucleus of an atom in a specified electronic orbits. Then next we are going to look about nucleus. So nucleus. The nucleus is the centermost core region of an atom. Usually in every atom possesses a central core and it is said to be a nucleus, and it is a positively charged particle. Usually the diameter of a nucleus is of the order 10 to the power minus 15 meter. And the nucleus will be consisting of two particles. What are they? Protons and neutrons. And this will be jointly known as nucleons. The protons are the positively charged and the neutrons has no charge. The next we will be looking about electrons. What is an electron? The space which is around the nucleus consists of another important particle, and we say it as an electron. And these electrons will be revolved are negatively charged particles, and they revolve around the nucleus at a distance which is varying. This distance that is which is similar to that of a planet, which will be rotating around the sun. And next we are looking about atomic number and mass number. What is atomic number and mass number? Atomic number. In 1913, H.G.J. Moseley, a scientist, stated that the atomic number of our atom is the number of protons which is present in the nucleus. And he said that it is also equal to the number of electrons in the atom, and he also said that it is represented by a letter Z. So, atomic number is the number of protons which are present within the atom. Next is about mass number. What is mass number? The mass number of an atom is the total number of proton and neutrons in the nucleus, and it is denoted by the letter capital A. And if an element is represented as X and its subscript will be Z, will be the subscript below will be said as Z and subscript above will be said as A. That is XZA. And the subscript here Z refers to the atomic number, and the subscript A will be refers to the mass number. The next is about electron orbits. What is electron orbits? What is electron orbits? Electron orbits are the places where these electrons are present, and they will be revolving around the nucleus with the specific orbits. And these orbits are also called as energy levels or shells. And there are different types of shells. We'll say it as K, L, M, N, etc. So, first starting, we will be starting will be from the K shell, L, M, etc. It will be moving in this random manner. So, this is about periodic table. Next is about neutrons. What is neutrons? Neutrons were discovered by James Chadwick in the year of 1932 when beryllium was bombarded with an alpha particle and highly penetrating radiation was emitted. And the Chadwick concluded that this particle possesses a mass which is nearly equal to the protons and have no charge. Then he called them as neutrons, and the reaction will be written as beryllium 49 plus helium 24 will be giving out of carbon 613, and this on again degradation will be forming of carbon 612 with the release of neutron and amount of energy. So next is about electron shell. What is electron shell? Electron shell is also called as electron orbit or valence shell, whatever it is. That is, in 1921, Bohr and Bury gave a statement for arrangement of electrons in an atom. According to their statement, the orbits in an atom will be said as shells or energy levels or electronic orbits. And he started it from K, L, M, N, etc. So the maximum number of electrons can be accommodated by a formula 2n square, where n will be said as 1, 2, 3, etc. So in K shell, n is equal to 1, and the numbers which can be accommodated will be n is equal to 2n square, that is 1 square, that is equal to 2. So in L shell, n is equal to 2, and the number of electrons will be n is equal to 2 into 2 square, that is equal to 8. So number of electrons in the L shell will be 8. So on this process, we arrange the electrons. So each shell will be provided with the subshells, that is S, P, D, F, etc. In K shell, n is equal to 1, and that has only one subshell, that is 1s. In N shell, it has two subshells, that is 2s, 2p. And one electron in the subshell of K shell will be noted as 1s1. If there is two electrons, it will be said as 1s2. And the outermost orbit will be said as valence shell, and this is responsible for chemical, optical, and electrical properties in the elements. The elements are arranged in the periodic table based on the similarities and chemical properties of different elements. So next we are going to look about periodic table. What is periodic table? The periodic table is the arrangement of all the electrons of which were discovered. So the chemical properties of the elements are largely determined by the number and arrangement of electrons in the outermost shell and not by the total number of elements in the atom. So hence, the atoms with the similar number of electrons in the outermost shell will have similar chemical properties, and this is the basis for the periodic classification of these elements. And when elements are arranged in the order of increasing atomic number, the elements having similar physical and chemical properties will be repeating at their regular intervals, and this is known as periodic law. And this was first formulated by Mendeleev. A tabular arrangement of these elements which are exhibiting their periodic properties will be called as periodic table. The elements with similar properties will be forming a groups, and they will be represented as vertical columns. That is, the group 1 will be consisting of hydrogen and alkali metals, and group 13 will be consisting of boron, and group 14 will be consisting of carbon, and group 16 will be consisting of nitrogen. Group 17 will be consisting of the fractions of halogens, and group 18 elements are inert gases. Usually they are inactive elements. And the horizontal rows in the tables will be called as periods. That is, after the third period, there appears a series of elements between the group 2 and group 3 elements. and these elements are called as metals. So in the period 6 there are 15 elements and they will be said as lanthanides, and the period 7 there are elements from Z is equal to 89 to 103 and they are closely related metals, so they will be called as actinides. And the periodic table will be providing a useful framework for the analyzing of chemical behavior and is widely used in the chemical and other sciences. So next we are going to look about isotopes and isobars. First, what is isobar? These are the atoms of different elements with same mass number and different atomic number. That is, for example, we can say nitrogen 717 and also oxygen 817. The next is about isotones. These are the atoms of different elements with same number of neutrons. That is, chlorine 613, nitrogen 714, but both will be having same number of neutrons. That is, neutron number for chlorine is also 7 and neutron is also for nitrogen, it is also the neutron number is 7. And next is about isotopes. These are the atoms which are having same element with same atomic number but different mass number. For example, hydrogen consists of 3 isotopes, that is 1H1, 1H2, 1H3. That is 1H1, that is hydrogen will be consisting of 1 proton, that is hydrogen. And 1H2 will be consisting of 1 proton and 1 neutron, that is deuterium. And 1H3 consists of 1 proton and 2 neutrons, and it is said as tritium. So isotopes of an element have the same chemical properties but are different physical properties. So isotopes which are capable of performing this radioactivity will be said as radioisotopes, and their nucleus will be said to be unstable. And usually there are two types of isotopes, that is radioactive isotopes and non-radioactive isotopes. The next is about isomers. Isomer is the metastable state of a nucleus, and it will be have the same number of protons and neutrons. That is for fluorine 918. It consists of 9 protons and also 9 neutrons. So next we are going to look about ionization and excitation. First we will look about ionization. Usually an atom is normally and electrically neutral. So if one or more orbital electrons are removed from the atom, the remainder of the atom will be left with the positively charged, and they will be said as positive ions. And this process of removal of an orbital electrons from the neutral atom will be known as ionization. Sometimes one or many electrons will be attached themselves to a neutral atom and form a negative ion. This is also known as ionization. So next is excitation. In excitation, in an atom, if energy is supplied, the electrons can be moved from the inner orbits to the outer orbits. Now the atom will have more energy than its normal state. So it is said to be in an excited state, and this process is known as excitation. For example, to move an electron from K shell to L shell of an hydrogen atom, the energy required is minus 3.4 electron volt minus of minus 13.5 electron volt, and that is about 10.1 electron volt. So usually this ionization and excitation process are generally needed in important in imaging techniques. So next in the summary, usually the physics, the basics are essential. So without this basic physical knowledge, we can't know what is there in physics. So foundation, it is also a foundation for imaging techniques, and is important for safety precautions or of safety about these elements or whatever it is. So everything, their basics are necessary. So that's all for today's topic. Thank you.